Okay, so what we're going to do today is just finish up 6.2. We've been working on this section and 6.1 sort of concurrently for the last few days. So we're going to try to get this finished up today so that we're ready to move on to the next section next time. All right, so I just want to show you a couple of additional examples similar to what we were doing in class the last time we met. All right, so I'm going to start with this one. We're taking the cosine of sine inverse of 1/3. And if you remember in class, we talked about looking at these values like the 1/3 and trying to determine if this was one of our memorized values, which it's not. All right, and so we're going to need a different way to find that because the question is still asking me what angle has a sine value of 1/3. And since this is something that I don't know, this is not an angle that I memorized a value equal to 1/3, then I'm going to have to come across and look at finding it in a different manner. All right, so what I'm going to do is I'm going to remember that when I'm talking about a sine inverse, that I am restricted to quadrants 1 or quadrants 4. That's the definition, remember, of the inverse sine. So if we're talking about a positive value, we're in quadrant 1. If we're talking about a negative value, we're in quadrant 4. And since our value is positive 1/3, then I'm going to go ahead and draw myself an angle in quadrant 1. And just like always, it's important that you get this angle in the correct quadrant. So again, because the 1/3 is positive and we're dealing with an inverse sine, we're going to draw our angle in the first quadrant. Okay, so once that's done, then the next thing that I'm going to do is I'm going to use what I know about a right triangle and the sine value. So I know that if this angle that we have just drawn, I'm going to call it theta, I know that that angle has a sine value of 1/3. So I know that if I'm dealing with a right triangle, I now have the, remember SOHCAHTOA, I have the opposite side and the hypotenuse. So I'm going to make a triangle by dropping a line straight down to the x-axis. That's going to include my angle, and I'm going to fill in the two sides that I know. Right, so I know that the opposite side, the side across from the angle, is 1, and the hypotenuse is 3. And then I know I can do Pythagorean Theorem to find the missing side. So I can say 1 squared plus the missing side, we'll call it b squared, is equal to 3 squared. And so 1 plus b squared is equal to 9. We'll subtract 1 from both sides. B squared would then equal 8. And then we'll take the square root of both sides. And the square root of 8 we could write as 2 times 4. I can't take the square root of 2, so I'll leave it underneath, but I actually can take the square root of the 4, and when I do that, that's going to give me a 2 on the outside. All right, and so now I know that this side is 2 on the square root of 2. And it is positive because we're moving in a positive direction and we're in the first quadrant. We know that everything's positive in that first quadrant. Okay, so remember that the question that we started with right here was what angle has a sine value of 1/3? So I don't know the exact angle but what I've now done is drawn a picture of it. Okay, so what angle has a sine value of 1/3? This picture right here is that angle. Okay, so in other words, this part of the problem is done. All right, I have a picture to represent that. So the last thing I need to do is find the cosine of that angle. And so that hopefully will seem pretty easy. We're going to go to our picture. I'm going to say, okay, I need to find the cosine of the angle. I'm going to remember SOHCAHTOA, so that is adjacent over hypotenuse. So my adjacent side is 2 on the square root of 2. That's the side next to the angle. And my hypotenuse is 3. Okay? And so this is just a little different than what we talked about last time, because instead of actually naming the angle, we're going to draw a picture of it. And then once we have that picture drawn and that right triangle labeled, we can find what it is they're asking us for. Okay, so I'm going to walk through 2 more examples just to give you a little bit more practice and a little bit more exposure to the idea, but they'll work exactly the same way. All right, so we're going to start with this one. And remember, we're starting inside the parenthesis. And the question that we're thinking about when we look at this is what angle has a cosine value of negative square root of 3 over 3. Now, negative square root of 3 over 3 or square root of 3 over 3 is one of the special values that we have memorized, but if you remember, it goes with the tangent and the cotangent, so it doesn't help me much on a cosine. All right, so the other thing that I want to remember is that if I'm dealing with a cosine inverse, that I am limited to quadrants 1 or quadrant 2. Quadrant 1 is where we have the positives. Quadrant 2 is where we have the negatives. So our value, negative square root of 3 over 3, is going to mean that the angle that I draw needs to be in quadrant 2. So I'm going to go ahead and sketch this angle. There's my initial side, and my terminal side will be somewhere in quadrant 2. All right, and technically this is my angle, but remember, in a case where we're in a different quadrant other than quadrant 1, we use the reference angle as part of our triangle. So your reference angle is sitting right here, and we want to draw a triangle to include that reference angle. So I'm going to drop my line down to the x-axis, and then we're going to fill in what we know. All right, so going back to our problem, we know that cosine of the angle, or cosine of the reference angle, either way, is equal to negative square root of 3 over 3. And I know that from my SOHCAHTOA definition that cosine is adjacent over hypotenuse. So we have 2 sides of the triangle that we can fill in. So the adjacent side would get the square root of 3. And it makes sense that that would be negative because remember, we're moving back towards the left. And the hypotenuse is going to be 3. All right, so just like before, we'll use Pythagorean Theorem, and that will enable us to find the missing side. So I'm going to take my negative square root of 3 squared plus the missing side we'll call b squared is equal to the hypotenuse squared. So when I square the negative square root of 3, that's just going to give me 3. And 3 squared is going to give me 9. And then I'm going to subtract 3 from both sides. And that's going to give me a b squared value of 6. All right, and then my b value is going to be the square root of that. Okay. So that enables me to come over here, and it is positive because we are moving up on that side. All right, so remember, our question originally was, what angle has a cosine value of negative square root of 3 over 3? That angle is shown in the picture, okay? So I can't name it and tell you exactly what it is, but I can draw a picture of it. And so once I've drawn that picture and have all three sides labeled, I'm done with that part. All right, so the last thing I need to do is actually do the calculation for cotangent based on that angle. So cotangent is going to be adjacent over opposite. So we'll take our adjacent side, which is going to be negative square root of 3, and we'll take our opposite side, which is going to be the square root of 6. Okay, now we have a little work to do because we know that we can't leave that radical in the denominator. So let's see if we can kind of get that fixed. All right, so I'm going to come up here so I've got a little room. So I need to multiply top and bottom by square root of 6. So that's going to give me negative square root of 18, 3 times 6. And then on the bottom, I'm going to get 6. All right, and so now let's look at the square root of 18. We want to simplify that. The square root of 18 could be written as 9 times 2. I can take the square root of the 9, that'll give me 3, but I can't take the square root of the 2, so it'll stay underneath. And so we have negative 3 on the square root of 2 over 6. And finally, doesn't seem like we're ever going to get there, we're going to reduce this fraction. 3 goes into 3 once, 3 goes into 6 twice. And so we end up with a final answer of negative square root of 2 over 2. All right, so a little bit tedious there with the simplifying, but otherwise the same process. Decide on your quadrant, draw your angle, fill in the sides of your triangle, and then find the part that they're asking for. All right, so let me do one more with you. All right, so we have secant sine inverse of negative 2 on the square root of 5 over 5. All right, so again, we start with the same question. We're looking right here. First, we're trying to determine what angle has a sine value of negative 2 on the square root of 5 over 5. I don't know, so I'm going to draw a picture. So when I think about that picture and I think about the fact that I'm using an inverse sine, we want to remember that on an inverse sine, you are limited to quadrant 1 or quadrant 4. Again, 1 is always for the positives, and the 4 in this case would be for the negatives. So I'm going to go to my graph and I'm going to draw a picture of an angle in quadrant 4 because my value is negative. And again, technically your theta is this angle that runs around here, okay, but we're going to use that reference angle and we can use that right in here, or you could rotate negatively either way, but this is the angle that we're going to be looking at. We're going to draw our line up to make a triangle to include that smaller angle. All right, so let's fill in what we know. All right, so on a sine, we know that we have the opposite and we have the hypotenuse. So the opposite is 2 on the square root of 5, and it is negative because we're coming down. The hypotenuse is 5. All right, so we'll find our missing side. just like we have in the other two examples. So I'm going to take 5 squared. That's my hypotenuse, and I'm going to, let me do it in the right order. Hold on just a second. All right, so we're going to take that -2 on the square root of 5 and square it. That's one leg, and the other leg we don't know, so we'll call that b, and we're going to set it equal to our hypotenuse squared. Okay, so when we square the negative, it's going to turn positive. When I square the 2 squared is 4, and when I square the square root of 5, it's just going to give me 5. So this parenthesis part is going to end up being 20. And 5 squared would be 25. We will subtract the 20 from both sides, leaving me just 5. And then b is going to be the square root of 5. And it will be positive because we are moving to the right with that side, making a positive square root of 5. All right, so again, once we've drawn that picture, we have finished this part of the problem. The only thing left now is to calculate our secant. So when I do my secant, remember that that's the reciprocal of your cosine. So that is going to be hypotenuse over adjacent. And so our hypotenuse is going to be 5. And our adjacent side is going to be the square root of 5. We're going to multiply top and bottom by the square root of 5 to rationalize that denominator. And that is going to give me 5 on the square root of 5 over 5. So my 5's will cancel, giving me a final answer of the square root of 5. Okay, so that's 3 examples of pretty much the same thing. I'm hoping that that's enough for you to get a pretty good feel for what we need to do on this type of problem. I'm going to assign a very short section in my math lab just to give you a little bit of practice. And then tomorrow I'll be recording lecture for the next section. We're going to start looking at solving trigonometric equations.